This is problem 9 from section 3.6, and this problem reads, a retail store estimates that the weekly sales S and the weekly advertising cost X, both in dollars, are related by this function we see here, and the current weekly advertising costs are $2,000, and these costs are increasing at a rate of $400. So we see that advertising costs are X, so we're solving for when X is 2,000. And we see that this part of the statement is describing a rate of change. So that is the change in advertising dollars, so that would be dx dt is equal to 400. So we see that we're dealing with an independent variable of time because everything is being described as weekly sales and weekly advertising costs. So we're going to take the derivative of this function with respect to t. So we'll start by writing d dt of s is equal to d dt of 40,000 minus d dt of 30,000 e to the negative 0.0005x. And the derivative of s is 1, but since the variable doesn't match the t variable, we get 1 ds dt. The derivative of a constant is 0, so this 40,000 is gone. We have our minus here, so 0 minus, and the derivative of 30,000 e raised to the negative 0.0005x. Well, e is its own derivative, but then when we follow by the chain rule, we have to multiply by the derivative of the exponent. So that gives us negative 0.0005. And because x does not match t, this follows with a dx dt. Now we want to plug in 2,000 for x and 400 for dx dt. So we can say that ds dt is equal to, and we're going to say negative 30,000 times e to the negative 0.0005 times 2,000. And now we want to multiply that answer by the derivative of the exponent and then multiply it by 400, the dx dt value. So times negative 0.0005, enter, times the 400 for the dx dt, and we get $2,207.28. And the online practice site asks that you enter this to the nearest whole dollar. So you would simply enter 2207 for your answer, and that would then be correct.